You know, when we look at data, say a wage survey or an education study, we naturally focus on what's right there in front of us. But what if the most important part of the story is what's missing? Today we're going to dive into the Nobel Prize-winning work of James Heckman, an economist who came up with an absolutely brilliant way to account for the data we don't see. And believe me, it completely changed how we understand the world.
So, here's how we're going to tackle this. First, we'll get into a huge fundamental problem that's lurking in pretty much all data. Then, we'll unpack the Nobel-winning insight that solved it. And finally, we'll see how this one big idea totally revolutionized everything from how we measure wages to how governments decide on massive social programs.
All right, so to really get why Heckman's work is so genius, you first have to wrap your head around a puzzle that sits at the very heart of statistics. It's the kind of subtle problem that can quietly and completely undermine almost everything we think we know. So, think about this for a second. Let's say you want to figure out the real value of a college degree. You can't just go out and survey people who already have jobs, right? I mean, why not? Well, because the group of people who are working right now is not a random slice of the whole population. The fact that they chose to work, well, that's where things get really complicated.
This huge problem actually has a name. It's called sample selection bias, and it happens anytime the group you're studying has in some way selected itself. And this isn't some tiny academic issue. It is a massive, massive challenge in almost all real-world research.
So, if we're only looking at the paychecks of people who are employed, we are missing a gigantic piece of the puzzle. The people who aren't working are just invisible in our data. And the key thing here is that their absence isn't random. It systematically twists and distorts the conclusions we draw from the numbers.
I mean, people choose not to work for all kinds of reasons, right? Maybe someone decides that staying home to raise their kids is more valuable to them than any salary they could get. Or maybe they have a health issue, or maybe there just aren't any good jobs where they live. These people are fundamentally different from those who are working, and because they're not in the data, it creates a serious, serious bias.
And this visual just nails the core challenge that Heckman took on. We can see the observed population, the people who are in our data set. But what we really want to do is say something meaningful about the entire hypothetical population, which includes everybody. How on earth do you bridge that gap?
Okay, so we've got the problem on the table. But here's the thing. Just spotting a problem is one thing. Actually figuring out how to fix it, well, that's what wins you a Nobel Prize. So let's get into Heckman's truly brilliant insight. Now, here's the absolute key. Heckman realized that these choices people make, like the choice to work, are endogenous. That's a fancy word, but all it means is that the choice comes from inside the very system you're trying to study. The decision to work is not some random, external thing. It's deeply tied to the potential wages we're trying to measure in the first place. You simply cannot pull the two apart. So, with this insight, he developed a powerful, and honestly, a surprisingly elegant method to fix this bias. It's a technique that's now become one of the most widely used tools in all of economics, and it's famously known as the Heckman correction. And the way it works is genius. It's basically a two-step procedure. Step 1, you build a model of the choice itself. You try to predict the probability that someone will choose to work based on things like their education, their age, whatever. Then, step 2, from that first model, you calculate a special correction factor for every single person. And finally, you just plug that correction factor into your original wage equation as a new variable. And like magic, that extra piece of information corrects for the bias, giving you a much, much clearer picture of what's really going on. And that critical correction factor? It has a name, of course, the inverse Mills ratio. And you can honestly just think of it as the statistical secret sauce. It's a single number that captures the hidden likelihood that someone was selected into your data in the first place. By adding it to your model, you can finally account for all those people who are missing.
Now, this was not just some abstract theory for academics to argue about. Oh no, this powerful new tool completely changed how economists and governments evaluate whether or not their social programs are actually working in the real world.
Just think about this for a minute. Let's say we want to know if a job training program is effective. We run into the exact same problem. The people who sign up for the program who self-select into it, they're probably more motivated, right? Or they have different skills than the people who don't sign up. Before Heckman, it was almost impossible to tell if the program was actually helping or if it was just attracting the go-getters who are going to succeed anyway.
Heckman's method gave us the tools to finally pull these two things apart. We can now separate the selection effect, that's the bias from who chooses to join, from the treatment effect, which is the real, actual impact of the program itself.
And being able to do this just blew the doors open for better research on a whole range of really important issues. All of a sudden, we had a much more credible way to measure the true impact of education policies, job programs, early childhood interventions, even to study incredibly complex things like discrimination in the workplace.
The impact of this work was, well, it was like an earthquake. It completely reset the foundations for modern research and dramatically raised the bar for what we consider to be credible evidence-based analysis.
And for this absolutely monumental contribution, in the year 2000, James J. Heckman was awarded the Nobel Prize in Economic Sciences. And the Nobel Committee's official reason? Well, they put it perfectly. It was for his development of theory and methods for analyzing selective samples. He didn't just find a problem, he gave us the theory and the tools to fix it.
You can actually trace this whole revolution back to a couple of huge, game-changing papers he published back in the 1970s. Today, those papers are basically required reading for anyone studying economics, and they form the bedrock of so much modern research.
So at the end of the day, what Heckman's work really gave us is a more honest way of looking at data. It allows us to understand when we can actually use data to test our ideas about the world, and, just as important, when we can't.
And that really leaves us with a powerful, essential question to carry with us. The next time you see a statistic, a poll, or a study, don't just focus on the numbers you see. Take a second and ask yourself, who isn't in this data? Who's missing? Because thanks to James Heckman, we know for sure that sometimes the data you don't see is telling the most important part of the story.